So this is the first page of the study guide, chapter 1. So here it's asking you to determine or to decide whether the statement is true or false. For this one, here you just need to understand some vocabulary terms. So it says point A lies on line M. Well, point A is right here. And you can see that, yes, it is on line M. So that's why that statement is true. Then the next one says point D, which is over here, lies on line N. Well, N is going this way. D is not located on line N, so that one is false. Then the next one, number 3, it says that points B, C, E, and Q are coplanar. Well, Q is up here. It's not on the plane, so that one is false. Then the next one, points C, E, and B are collinear. Well, C is here, E is here, B is here. They are not all on the same straight line, so this one is false. They are not collinear. And then another name for plane G would be QEC. Again, Q is not on plane G. It's up above it, so this one is false. Then for number 6, it wants us to find the length of HJ. HJ is right here. So in order to find that length, I'm going to take the total length of HK and subtract out JK, and I get 22. Then to find the length of BC, which is here, again, I'm going to do exactly the same thing, and I'm going to do 18 minus 7, and BC is 11. The last one, instead of subtracting, to find the length of the entire segment, I'm just going to add 26 plus 45, and I get 71. Now, all right, so this was whited out on your study guide, so I'm going to do number 12, though, and it says the midpoint of AB is the order pair 9, 7. I'm going to go ahead and label this as the X of my midpoint and the Y of my midpoint. And then they're giving me an endpoint, which is order pair A, 3, 9. They want me to find the missing order pair, B, and I'm going to call that X2, Y2, because this will be my X1, Y1. So the formula for midpoint is going to be to take the X's, add them and divide by 2, and that gives you the X of the midpoint. Do the same thing for the Y's, add them and divide by 2, and it gives you the Y of the midpoint. So I'm going to go ahead and take the given information from my order pair, and I'm taking the X of the midpoint, and I'm going to put it here. I'm going to take this Y, this X1 out of my order pair here, and I'm going to place it right here. What I'm solving for is the X2, or the X sub 2. So let me go ahead and replace what they gave me. So I'm doing 3 plus X sub 2, or X2, divided by 2 is going to equal 9. I need to work backwards. So the first thing I'm going to do is get rid of the fraction by multiplying both sides by 2. And then I'm left with 3 plus X2 equals 18. Subtract 3. And the X of my endpoint is 15. I now need to do the same thing with the Y. So I'm going to go ahead and grab my 7 here from my order pair. Let me do a different color here. So I'm going to grab that one. And then I'm also going to go up and get the Y of the order pair. So I'll go ahead and grab that one. And now I'll plug it into the formula. So I'm going to do 9 plus Y2 divide by 2 equals the Y of the midpoint, which is 7. I'm going to multiply both sides by 2 to clear the fraction. And I end up with 9 plus Y2 equals 14. Subtract 9, and Y sub 2 equals 5. So my order pair for my endpoint is 15, 5. This is going to be point B. Now for number 13, it tells me that line T bisects CD. Let me go ahead over here, and I'll do 13 on the side. So I have CD, a segment here, and it's telling me that point T, or line T, sorry, line T bisects CD at point M. So it's telling me that CM here, this side equals 3x, and this side equals MD equals 27. So what I need to do is set them equal to each other. So 3x equals 27. I'm going to divide both sides by 3, and I get x equals 9. Now, it didn't ask me to find what x equals. It asked me to find the length of CD. So if I take CM plus MD, that's going to give me CD. CM was 3x. MD was 27. So I just have to do 3 times 9. And I get 27. So 27 plus 27 is equal to 54. Now, honestly, if you recognize that this segment was bisected, you could have just taken the 27 and doubled it and not done the whole solving for x. However, if they would have asked you to find x, that's how you would have done it. So the answer for CD, the length of the whole thing, is 54. Then for number 14, this one was taken off because I'm not going to expect you to use a protractor. For number 15, we're using the diagram, and it's telling me that angle KHJ, which is right here, is a right angle. It's 90 degrees. It wants me to find the measure of angle LHJ, which is over here. So what I need to do is I can add these two together and set them equal to 90. So I'm going to add 8x minus 1 plus 4x plus 7 and set it equal to 90. I'm going to add my like terms. 8x plus 4x is 12x, and then negative 1 plus 7 is 6. I'm going to subtract 6. 12x equals 84. Divide 84 by 12. I get x equals 7, but now I have to take what x equals, and I need to plug it in here. So angle LHJ was equal to 4x plus 7. So 4 times 7 plus 7, 28 plus 7, and the answer is 35 degrees. For number 16, this one, a picture was not provided, so I'll go ahead and sketch one. It says the measure of QRT is 154 degrees. So I could put letters here, Q, R, T. And then it says RS bisects that angle. So I know when an angle's been bisected, it is going to split the angle into two congruent pieces. So QRS is right here. So all I have to do is take 154 and divide it by 2. And each side is going to be 77 degrees. So both QRS and SRT are both going to be 77 degrees. For the next one, it wants us to name 4 linear pairs. So the linear pairs are over here. So 1 and 2, 2 and 3, 3 and 4, and 4 and 1. But let me go over to the diagram. So I have a linear pair right here. 1 and 2 together form a linear pair. Then I could do it this way, and 2 and 3 form a linear pair. And then I could do it this way, and 3 and 4 form a linear pair. And then I could also go this way, 1 and 4. So I have all those sets of linear pairs in the picture. The next one wants me to name the vertical angle pairs. So I have vertical angles here, 2 and 4 are vertical. And then I also have 1 and 3, which would be vertical. So those are the vertical angle pairs. And then the last one here, the measure of an angle is 64. So for the complement, these are two angles that add to be 90 degrees. So I'm going to do 90 minus 64, and I get 26 degrees. For the supplement, these are going to be two angles that when you add them, they add up to be 180. So subtract 180 minus 64, and I get 116. So just understand the vocabulary words complementary and supplementary. Okay, so for this one, again, I took off these two questions. I'm not going to give you pictures that you'll have to complete the pattern, but I might give you numbers. So notice in this pattern, to go from -6 to -1, we added 5. Same thing here, add 5, add 5. So it's increasing by 5. So to get the next number in the pattern, I just do 9 plus 5, and the next number is 14. For the next one, it looks like it's either, think of it as divide by -2, or you could also have thought of it as multiply by -1/2. Either way, it's the same thing. So if I take -12.5 and divide it by 2, I get positive 6.25. Now for numbers 5, 6, 7, and 8, just refer to the document that is in the assignment, because here are all the sentences for number 5. Here are all the sentences for number 6, number 7, and then lastly, number 8 down here. So you can just read through the sentences. Make sure that you understand how to write an if-then, a converse, an inverse, and a contrapositive. Understand those definitions of those words in order to write it. Now, also for number 9, you need to understand how to apply the law of detachment. And then number 10, the law of syllogism. So for the law of detachment, as long as the statement that is given to you is true and it applies to the true hypothesis. So tonight you're going to the football game. So here the hypothesis was if you decide to go to the football game, then you will miss band practice. So because you went to the football game, your conclusion is you will miss band practice. Remember, for the law of syllogism, it's sort of like transitive, where the conclusion of the first statement will cancel out the hypothesis of the second. So my first statement was if Margot goes to college, then she will major in chemistry. Then the second statement was if Margot majors in chemistry, then she will need to buy a lab manual. So what's happening here is the conclusion of the first one matches the hypothesis of the first one. So your final answer is just taking the original hypothesis and putting it with the conclusion of the second. So this is your final statement. If Margot goes to college, then she will need to buy a lab manual. For number 11, 12, and 13, we're using the diagram, and we need to apply what the postulate states. So there's more than one answer on these. Notice the instructions or the answers say sample answer. So it says a line contains at least 2 points. So the example they gave were MP. So MP, line MP, that contains 2 points. You could have also said MN. What was important is because it had line, you had to put the picture of a line on top, or you would have needed to wrote the word line in front. You could have also used this other line that was here. You could have said RS. So you could have said line RS contains points R and S, or even RN. So multiple answers on this one. For number 12, a plane contains at least 3 non-collinear points. So what they did was they gave the example for plane X, and they named 3 non-collinear points that were in plane X. So they used M, Q and P, notice they're not all on the same line. You couldn't have used M, N, and P because those were collinear. Now you could have also named 3 points in plane Y. You could have said S, Q, and R. So just pick any 3 points in that plane that aren't on the same line. And then the last one, 13, it says if 2 planes intersect, then their intersection is a line. So plane X and Y intersect right here at line NQ. You could have also named it TQ or TN, any 2 points on that line. Then the next one, this is where we were introduced to your algebra proofs. So for number 14, it's over here. Remember, when you're setting it up, the equation here, this side would have been the statements where it says equation, and then the reasons. So the problem that they give you to solve is given. And then from there, I subtracted 31. So subtraction property of equality. And then division property of equality. Then number 15, this one, they actually divided by -7. In this particular question, you could have also done distributive property, and you could have distributed the -7 instead of dividing. So that's the other way to do it. So if you did this and your reason was distributive, that was fine as well. Then number 16, this one you had to distribute, you couldn't divide, so you had to follow the steps that they did. So distribute, then you would have combined like terms. So where it says simplify, if you put combined like terms, that would be acceptable as well. Okay, and then you just continue solving. You would have simplified, then subtracted, and then divided. Then number 17, 18, and 19, you're just identifying the property. So 17 is the symmetric property. Think of the word then like the line of symmetry, and these all match. We've used number 18 quite often. That is our reflexive property. And then 19 is transitive. Notice the JKs cancel out, and you can conclude that FG is congruent to LM. And then number 20, it wants you to find the value of the angles. So we know that vertical angles are congruent. So I'm going to set up 2 algebraic equations. I would set these 2 equal to each other, and then these 2. So for the purple ones, I'm going to set 7y equal to 5y plus 36, subtract 5y, 2y equals 36, divide by 2, and y equals 18. Now, it didn't ask me to find the value of y, it asked me to find the value of those angles. So what I would do is take the 7y, plug in 18, so 7 times 18, and I get 126. So these 2 angles are both 126. And then to do the blue one, you're going to set 3x minus 21 equal to 2x plus 4. So you'll subtract 2x. X minus 21 equals 4. Add 21. X equals 25. And again, you got to plug it in. It doesn't matter to which one. If I plug it into the 2x plus 4, I do 2 times 25 plus 4. 50 plus 4, and both of those angles are 54 degrees. And then the last one, the proof. So what they're giving us is that AX is congruent to DX, and XB is congruent to XC. Now, we're not told that this is a rectangle or a parallelogram. This is all we're given. They want us to show that AC here is congruent to BD. So this is where I'm going to bring in my segment addition postulate. Now, here is their answer down here. What they did was they changed the congruency symbol to an equal sign. So if you wanted to just keep working with the congruency symbol throughout, you could have skipped step 2. But then just know that over here, this would have been a congruency. And then from there, you didn't have to show this step here. This would have just been transitive. So you could eliminate switching back and forth from an equal sign to a congruence. All right, so instead of crossing it out, so you could have done it this way using all those official properties, but let's say instead you wanted to just work with congruency signs throughout. So statements and reasons. So number 1, AX congruent to DX and XB congruent to XC. And that was given. Now, what I need to establish is I need to get the letters AC and BD into my proof. So I'm going to show how AC and BD are made up. So I'm going to actually show you that AC is made up of adding AX plus XC, and it equals AC. And then I can do DX plus XB equals BD. And this is my segment addition postulate. And you can abbreviate it as SAP if you wish. Now that I've established how it's made up, now what I'm going to do is I'm going to do a substitution. So what I want to show are that these two things are equal. So what I can do here is I'm going to replace AX, this right here, with what AX equals, which is DX. And then on this one, I'm going to replace, so on this one, I'm going to replace this one with XC. So then they're going to look similar. So let me rewrite. So I'm going to do a substitution. So I'm taking out the AX, which I underlined in red. I'm going to replace it with DX. And then I have plus XC equals AC. And then for the blue one, I'm leaving the DX, but I'm replacing XB with XC. And this is substitution. It can't be transitive. Now, because they're both equaling the same thing, now what I can do is a transitive or a substitution. And now I can, and I would have left these as congruents. And now I can say that AC is congruent to BD. And that would have been either substitution, or this one could have been transitive. Because what happened is this canceled out. That was the overlap. Actually do it in 4 steps instead of 6. So for chapter 3, these are just identifying the special angle pairs. So notice I've got my 2 lines and then I've got my transversal. So 1 and 8, these are alternate exterior. Then 2 and 6 are corresponding. 3 and 5 are consecutive interior. Now, if these lines were parallel, then I would have the consecutive interior would be supplements and all the other ones would be congruent. But we're not told that these lines are parallel, so all we can do here is identify the special angle names. Then 4 and 5 are alternate interior, and then 3 and 7 are corresponding. And then 3 and 6 are also alternate interior. Now that they're telling us that the lines are parallel in 7, 8, and 9, now I can find the measure of the angles. So for number 7, I know that these are both corresponding angles, so that's why x is equal to 140. For number 8, these are actually alternate interior angles, and alternate interior angles are congruent. So I'm going to set these two equal to each other. 18x equals 72. Divide by 18, and x equals 4. Then for number 9, this is a pair of alternate exterior angles, which are also congruent. So 4x plus 11 equals 107. Subtract 11. 4x equals 107 minus 11 is going to give me 96. 96 divided by 4 is 24. Now for 10, 11, and 12, we're doing the same thing. We're identifying the angle pairs. So these are actually same side interior, or they're supplements. So to find the measure of angle X, I just do 180 minus 137, and the answer is 43. Then for the next one, these are corresponding, and they're congruent. So for number 11, I'm just going to take 128 minus X and set it equal to X. I can add X to both sides. 128 equals 2X. Divide by 2, and X equals 64. For number 12, these are not special angle pairs. They're actually supplements. But what I could have done on number 12 is recognize that these two guys are vertical. And then now these two are supplements because they're consecutive interior. So what I'm going to do is add X plus 17 plus 73 and set it equal to 180. X plus, add 17 and 73, and I get 90. Subtract 90 from both sides, and X equals 90. So let's go ahead and see how many of these I can get done. So for number 13, 13, 14, and 15, we need to know the slope formula. Remember that slope formula is y2 minus y1 over x2 minus x1. So for number 13, I'm going to plug in. This could be my x1, y1, and this order pair, my x2, y2. So I'm going to subtract 4 minus negative 1 over 3 minus 3. You need to be able to interpret that when you get a 0 in the denominator, this has an undefined slope. If the 0 would have been in the numerator, then the answer would have been 0. For number 14, same formula. I'm just going to go ahead and plug in x1, y1, x2, y2. And I'm going to do negative 3 minus 7, negative 1 minus 2, negative 10 over negative 3. Negative divided by a negative makes this become positive 10 over 3. Then number 15, same thing, x1, y1, x2, y2. And it doesn't matter which one you label as order pair 1 or order pair 2. You get the same answer either way. So 12 minus 5 over negative 6 minus 0. I get 7 over negative 6. And again, just recognize that when there's one negative in the fraction, it could have been pulled to the front of the fraction. So just in case this ends up being a multiple choice question, be able to recognize that these two mean the same thing. Now for numbers 16, 17, and 18, it wants us to write an equation of the line that passes through that point and has the given slope. Now this could also be stated as find a line that's parallel to a given line. So remember, parallel lines have the same slope. So for number 16, I'm going to take my order pair. This is going to be my x and my y. And then the slope they gave me is 3. I'm going to be plugging that in to y equals mx plus b. I need to find the b first. And then once I get the b, I plug that back in with the slope. So I'm going to replace the y with 4, my slope with 3, my x with negative 2. I'm going to multiply. I'm going to add 6. And the b, or my y-intercept, is positive 10. So my equation, I'm now going to take my newly found b as well as my slope and plug it back into y equals mx plus b. So y equals 3x plus 10. I'm going to do the same thing on number 17. 17. So this order pair was 7, 12. The slope they gave you was negative 2/10. So again, I'm going to plug in 12 equals negative 0.2 times 7 plus b. 12 equals negative 1.4 plus b. I multiplied the negative 2/10 with the 7. I'm going to add 1.4 to solve for b. And I get 13.4 equals b. And now I take my b and my given slope and plug it back in. So my final answer here is y equals negative 0.2x plus 13.4. Number 18, exactly the same thing. I'm going to take the order pair, 3, 5, and my slope was negative 8. I need to find the b. So 5 equals negative 8 times 3 plus b, negative 24 plus b, add 24, and my b is 29. So now take my newly found b and the slope and plug it back in. So y equals negative 8x plus 29. So for number 19, this time it says to write an equation of the line passing through the point P and is perpendicular to the given line with the given expression. So for 19, they're giving me the order pair 1, 3, and they're giving me the equation. So this is going to be my x and my y, and they're giving me an equation. So I want a line perpendicular to this one. Remember, perpendicular lines have opposite reciprocal slopes. So the slope of this line is 2, and I can make it 2 over 1. But the perpendicular slope is opposite sign and flip the fraction upside down. So I'm going to use the perpendicular slope and this order pair for my x and my y. So I'm going to plug it in. So I need to find the b. So I'm plugging it in again to the y equals mx plus b. So my y is 3. My slope is negative 1/2. My x is 1. And then there's my b. I'm going to go ahead and multiply. I need to add the 1/2 to the other side. Now this is just a whole number adding a fraction, so this could just become 3.5 is my b. Now you could also write your b as an improper fraction, so be able to recognize both. So now I'm going to take my newly found b, either form, along with the perpendicular slope, and plug it into y equals mx plus b. So y equals negative 1/2 x, and then you can either put it in as plus 3.5, or recognize that it could also be negative 1/2 x plus 7 over 2. You might also see it written as a decimal. Actually, it could also be y equals negative 1/2 x, or actually I could put the whole thing as a decimal. I could make it negative 0.5x plus 3.5. So be able to recognize all the different forms if you're ever presented a question like this in a multiple choice setting. So let's try number 20. Exactly the same thing. I need to take my given, and it's the order pair 0, 2. Now, if you recognize that when you have an order pair and they list a 0 as the x, this is the y-intercept. So technically, I don't have to plug everything in. All I need to do is find the slope of the line. So the given equation was y equals negative 1/2 x, or negative x plus 3. So what I need to do here is the slope of this line is negative 1. the perpendicular slope is going to be positive 1. So I'm using this, and if you recognize that this is the y-intercept, you could just go right into the equation. It's just 1x plus 2. Now, if you didn't recognize it, here is the work for it. You would plug in the 0, 2 as your x and y. So 2 equals 1 times 0 plus b. 1 times 0 is 0. So your b is 2. And then you just take that, and you plug it in. So you didn't technically have to do the work of plugging in the order pair 0, 2 because that order pair was the y-intercept. For number 21, exactly the same thing. However, we need to rearrange the given equation into y equals mx plus b form first. Let me go ahead and go over here for 21. For this one, the given order pair was 2, negative 3. And then the equation was x minus y equals 4. I need to get this equation into slope-intercept form because I need to get the slope. And then I need to turn it into opposite reciprocal. So let me go ahead and subtract the x. Then divide everything by negative 1 because I can't have a negative y. And y equals positive 1x minus 4. So the slope of this line is 1. However, the perpendicular slope is going to be negative 1. I'm now going to plug it in. So negative 3 equals negative 1 times 2 plus b. Negative 3 equals negative 2 plus b. I'm going to add the 2. Negative 1 equals b. Take the b, take the perpendicular slope, and your equation is going to be negative 1x, so just negative x minus 1. And that would be an equation of the line that is perpendicular to this equation going through this order pair. So in number 22, this is where it's got the figure now, and they're telling us that line or segment A, or actually it's ray AB, so this is perpendicular to BC. So I know that perpendicular lines are going to form right angles. So I actually have a little right angle here. So in order to find the value of x, if you wanted to set it up algebraically, you would do this. But really all you needed to do was subtract 90 minus 68, and x equals 22 degrees. Same thing on number 23. Since the lines are perpendicular, this is a right angle. So in order to find the value of x, I'm going to add 3x plus 51 and set it equal to 90. I need to subtract 51 from both sides. So 90 minus 51 gives me 39. And then divide 39 by 3. And I get x equals 13. We're going to do exactly the same thing on number 24. Again, we were told that these lines are perpendicular, so this is a right angle. So in order to find the value of x, I'm going to add x plus 8x plus 9 and set that equal to 90 degrees. I'm going to combine my 1x and my 8x, and I get 9x. I'm going to subtract 9, and I get 9x equals 81. Divide both sides by 9, and x equals 9. Okay, so for this page, this is where we learned about classifying triangles by its side length. So notice on this one, all of the sides have congruency marks, making this an equilateral triangle. Remember, it's also equiangular. So remember, the three angles of a triangle add up to be 180. So if you divide 180 by 3, each one of these angles is going to be 60 degrees, making it an acute triangle as well. Now this one, I know there are no marking on the sides here, but you can tell it's a right triangle. And then here, all three sides look like they're different lengths, making it scaling, where all three sides are different. I would give you congruency marks. I wouldn't expect you to assume that they're all different sizes. Now number 3, you can see here that this has got congruency marks, making it isosceles. And then this angle is definitely greater than a 90-degree angle, making it obtuse. For numbers 4, 5, and 6, we're going to use our triangle sum theorem, where we learn that the 3 angles of a triangle add up to be 180. So I'm going to go ahead and add the 2 angles I have, because if it asks you to write an algebraic equation, the algebraic equation would be to take the 3 angles and add them and set it equal to 180. So I'll add 30 and 80 and I get 110. Then just subtract 110 from 180 and x equals 70. I'm going to do exactly the same thing on number 5. I'm going to add the 3 angles. Now the shorter way to do this is we learned a corollary that stated the 2 acute angles of a right triangle are always complementary. So the faster way to do this, so you could either set up this equation and do x plus 2x plus 90 and set it equal to 180. Or the other way you could do it is just do x plus 2x equals 90. Because I know that these 2 angles are going to add to be 90. Either way works. This gives me 3x equals 90. Divide by 3 and x equals 30. If I did it this way, I would have gotten 3x plus 90. I would have had to subtract 90 first and then get the same thing. 3x equals 90, divide, and then x equals 30. Either way you can solve it. So you either use the corollary that states the acute angles of a right triangle are complements, or use the triangle sum. For number 6, what I need to do here is find the value of x. So if you recognize that this is a vertical angle pair here, the bow tie, then I can just take x plus 50 plus 55 and set that equal to 180. I can go ahead and add, and I get 105. Then I have to subtract 105 from both sides, and I get x equals 75. So this one brought in vertical angles as well as the triangle sum. Then for number 7, this one states that in the diagram, DEFG is congruent to WXFG, and it wants us to find the values of x and y. Now, remember, when we have congruent figures, that's going to mean that the angles are congruent as well as the sides. So, for example, to find x, x is located over here, and that is GW. So GW is the first and the last letters here. So I'm going to be matching it with the first and the last letters here, which is going to be this DG. So in order to find x, I'm going to set 3x minus 5 equal to 10. I'm going to add 5. 3x equals 15. Divide, and x equals 5. Now to find y, again, I can tell that this is a right angle right here. So what I can do here is I can set 15x plus y equals 90, because this is a right angle here. I can replace x with what I just found it to be. So I could put a 5 here. And now I can multiply. So 15 times 5 gives me 75. And then I'm going to subtract it from both sides. And I get y equals 15. All right, so we are not doing transformation, so you can skip that question. Now the next one, it says decide whether the triangles can be proven by the given postulate. So in our book, they were all theorems. So remember, side, angle, side. We need two sides marked with a congruency as well as the included angle. So I can mark this included angle here because it's vertical. So I have side, angle, side on both of them. So that's why, yes, you can. It could be proven. Next one wants angle, side, angle. So on this one, if you recognize that these are equiangular, that also tells me that all these angles are going to be 60. So they're all congruent, which would make them congruent here as well. So I do have angle, side, angle here, just because I know all the angles in an equilateral triangle are all going to be 60. And then this one wants to know, can you do side, side, side? Yes, you can. You can add in the reflexive and say that, yes, we have side, side, side on all of them. So again, I would be paying close attention to these triangle shortcuts for the midterm. Then number 12 says to write a proof. All right, so it says here to write a proof. So let me go ahead and, so there is the answers there, but let me go ahead and rewrite it. So statements and reasons. So number 1, triangle ABC is isosceles with base AC and BD bisects angle B. This is given. So let me go ahead and label the picture here. So these are congruent, and because it says this is the base. So then it also says that BD is bisecting this angle up here. So this would make these two angles congruent. So it wants me to prove that this little triangle here, ABD, is congruent to CBD. So far, I have two things marked as congruent. So the next thing I need to do is what I just marked in the picture. I'm going to use that BD as that angle bisector. So I actually need to label or name those two angles that I just marked as congruent. And I can go ahead and also add in the congruency marks that I added on the sides. So I need to state that AB is congruent to BC, and this is definition of an isosceles triangle. And then I'm also going to name that angle up there that I labeled. So the ABD is congruent to angle CBD. And this is definition of an angle bisector. Because when a larger angle has been bisected, then it splits it into two congruent pieces. Then the next thing I can add in is my reflexive side, this BD. And now I have enough to prove it's congruent by side, angle, side. Because I got a side, an angle, and a side. So this side and this side match, the two angles here, and then the reflexive side. So my next statement is going to be that reflexive side, that BD is congruent to BD, reflexive, and then now I can state what they asked me to prove, and my reason is side, angle, side. So they asked me to prove that triangle ABD is congruent to triangle CBD, and this is side, angle, side. So the last one says, what is the third congruence needed to prove that triangle PQR is congruent to STU using the indicated theorem. So in order to show that these are congruent using hypotenuse leg, I would have either needed a congruency mark on this leg and this leg, or a congruency mark on these two. So the correct statement should have been either stating that PQ or QP is congruent to TS, the green one, or the red one, the QR, congruent to the TU, what I put the red marks on. So either one of those. So you would have needed, they already gave us the right angle and they gave us the hypotenuses marked. I needed a leg that was marked. And then now to show angle, side, well, I could have stated that my right angles are congruent, but then I would have also needed congruency marks on either angle P and show that that is congruent to angle S, or that R was congruent to U. Because I would have needed angle, side, two angles marked, and then one side, but it couldn't have been the included side. So that was it for that page.